This is Pactive Evergreen Canton Mill lime kiln production. So I took a year's worth of data for everything number 4 and everything number 5 lime kiln, all the tags that they have listed in their system that I could find, just to see what we got. As a matter of fact, I'm almost thinking this might be a really good exercise to do with art. Like, okay, we have this data set. Here's the problem we know the customer has. What do we do? Like, how would you start breaking this file down? So anyway, I was kind of playing around with it because one of the things I'm trying to help them figure out and help us figure out is scoping, like what are we going to do to help get the lime kiln up? So I wanted to find out how bad they were. So lime kiln number 5 is the bigger of the two. It should be making about 160 tons a day. So top graph is the 24-hour average production. So basically it's a rolling 24-hour average.
Right.
So basically I just summed it up by month. And so they're averaging, about 137 tons on average, against 160 tons is what it can produce. They've hit it, basically 3 times, 3 months. And they're trending downward over time over the last 2 years. So they used to be up here in the low 140s. Now they're under 140, so they're more like 135. So then I kind of did the same thing. I just said, what's the production previous day? And I'm just taking the average of the day, to get these numbers. Basically the same graph, kind of came up with the same numbers, which are what I figured. But I just wanted to see if there was any differences in that. Sometimes you get some little nuanced differences. And then here's the uptime, the percent uptime, just like a rolling average. Like, how have we done the last 24 hours? What percent up have we been? So 100% is the green line. So as you can see, and some of these, like, they may have had an outage, like in September where they took the whole thing down. So, I mean, some of that you got to, like, filter out. But just in general, again, less uptime. Their average is about 90%. If you could get it up to 95%, close this gap by half, that's a lot of money for them. So,
Sure.
So anyway, there's a whole bunch of data. 2 years worth of data, and I think there's 250 columns ish.
Goodness.
Right. So what I'm thinking, is like, okay, Art, let's just import this into Simca and see what relates to what. Right? We don't know anything. Let's just explore.
PCA?
Yeah.
Yep.
Yeah, let's just do a PCA on it. I already know there's got to be a ton of data cleanup on it because, I went in here. If I go into the transform data, I did a whole bunch of crap to it because I was getting a whole bunch of errors. So I did a whole bunch of replace values. I would just highlight everything and say, okay, every time you see shutdown, replace it with nothing. No data, replace it with nothing. Bad input, nothing. So I just got all the normal, like, stuff we could find. Calc failed, point created, IO timeout, under range, over range, all that kind of stuff. So that just replaced all that. So I'm like, okay, and you can do that in Simca, right? He showed us, like, if you have an error,
Yes.
you can replace it. So let's walk through that, so that we can do that. Let's look at that kind of heat map that he was showing, of the data, which was really cool, where you could see where you had missing data. Tell us what you see. So I think it'd be really good for us as an exercise to go through something that makes sense to us, but yet we don't really know much about this.
Yep.
Like, all right, I just got this data file. What do I do? Right?
Do they have any concerns if we do that?
Are
they NDA out the wazoo?
It's not. Yeah, we have an NDA with them, but I'm not really showing any of the data per se. I'm not gonna. That's not the goal. And I might be able to even matter of fact, I may anonymize it before we do that. So that's a good point, just to make sure we're covered.
Yeah.
Because Sartorius would not have an NDA with them, so I'll anonymize the data.
Okay.
So I can do that before Monday for sure.
All right.
And I don't know I don't even know if we'll do it Monday. We may do it like week 4. I think.
Okay.
Do y'all?
I think he said week 4.
Yeah. Don't you think that'd be like the most valuable thing we could do? You know, is just
Yes.
Real world example.
yeah, real world walk us through this.
100%.
You know, and see what we could do.
What's related and what's different between the 2 periods of time, basically.
Yeah.
Yeah, and I could even build like a a feature, to say like if your 24-hour average production is say under like 130, compare that to above 150 and call them good and bad. So we make 2 classes, so we can do OPLS. So I can just do a quick rule to say, hey, if the tons of the previous day was 130 or less, call it bad. If it's 150 or above, call it good. Go ahead, Katie.
Well, yeah, okay, that makes sense. I thought you were going to do that on average.
No,
Yeah.
I'm talking doing it on a day-by-day basis. So in other words, this day's good, this day's bad.
I wonder if you'll get any skew because you might run well for a few hours out of that day.
Well, I think that's why you look at the how much you actually produced.
I think this is all questions for Art, is how to attack this.
Right.
Yeah.
So that's what I want to get at.
Yeah.
I don't know if we need the classification other than just see if there are any groupings, or maybe just do some like color by kind of things or whatever, just to be like, okay, maybe it's
Well, I think from
things that are high here, low here.
From an OPLS example where you want to compare 2 sets of data and say what's different between them. So in other words, what are we doing different when we're running like crap versus when we're running more toward our target?
But what I'm saying is you don't have to use that, right? You can just color by and see what groups naturally. So maybe you'll see like a distinction rather than prejudging it. Does that make sense?
Yeah, you could. Yeah, for sure.
Yeah. Anyway, we can ask Art how to do that.
Yeah.
I think it's a good idea, though, to do that, to make it a real-world example for us.
Yep.
Yeah.
Okay.
Good idea.
Okay. So,
All right, where do you guys want to start?
I did that one.
yeah, I finally figured it out, because we actually went
Instructions
over
suck.
this task 2 and task 3, but I thought we could like kind of run through it. Abel, which ones have you done? Katie, which ones have you done?
I did champagne and cava. I haven't gotten far.
Okay.
Foods, healthcare, ESD, champagne and cava, I got stuck, like,
Okay.
somewhere.
Okay. All right. Well, let's go through the champagne and cava here. I'll just save mine.
Yes.
And then let's just go through it.
Yeah.
Agree.
Because this one I got stuck too, but then like I reread it this morning or just a few minutes ago and was like, oh, that's that thing he just showed us last week.
Yeah.
Oh, okay. But then I'm like,
Let's do it.
what does that mean again? All right.
Yeah.
So let's just do a new project, a new regular project.
They've got some stuff in here too where like they don't fully explain how to set it
Exactly.
up,
Yeah.
That's
and
where I've
that's
gotten lost.
annoying. Yeah.
Yeah. And that's why I figured let's just go over it, and then that way we've got questions we can specifically ask. All right. Yeah, I think this was the trickiest one that I had done. Like I did the PSD one, I kind of got that one, and he went over that one. And that was a getting
Oh,
started.
yeah. Yeah. Okay, that's right.
The healthcare one I didn't do because he kept using that data set. So I was like, all right, let me just try champagne or cava.
Yep.
Because that was
Right.
totally different. So this was the champagne or cava train and predict. Or was this?
I also found out if you click the champagne and cava, like if you click the wrong thing, it blows Simca up. So that was good.
Oh, lovely.
Yeah, that's not good.
All right, so we're doing the champagne and cava predict. All right. So you guys kind of read out the instructions. Okay, what am I supposed to do here?
Pulling it up real quick. Anybody else have it up?
Yeah.
You select both.
Okay.
Huh?
Oh, and hit OK.
Okay. But I see that you can merge some stuff, merge side by side,
Yeah,
match on
it
rows.
wants separate sheets.
Yeah. Okay. Bless you, bless you.
Bless you.
Yeah, I don't know where that came from.
And then use column 2 as a class identifier on both sheets.
So this,
Class ID. Yep.
okay. Do you guys know what the difference between a class ID and qualitative actually is?
The class ID is just like a header or like an identifier versus the qualitative is like actual data being used, right?
Correct. Yeah.
Okay.
The class
One
ID.
gets built into the model, one doesn't, I guess.
Yeah.
Yeah.
The qualitative is just like on, off, true, false, you know, which phase it is, etc. It's just words. You know, whereas quantitative is like numbers, right?
Yeah.
A class ID is like, hey, I want to compare all the C's versus all of F's and see what's different, kind of a thing.
Your groups.
Yeah. Your group.
Or what you're going to try to predict eventually, right?
Yeah. All right. So that's class ID. All right.
And do that on both sets. So prediction set and training set.
Okay.
Yep.
All right. What else do I do?
Finish the import.
Finish
Okay.
import.
Yeah, and you see we have no issues. Usually you have issues down here
Yeah.
that you have to resolve, so they made it easy on us.
Yeah.
And you do realize you can exclude stuff here, right? You can pick,
Yeah.
you know, I can say, okay, I want to make this a Y variable. You know, you can do all kinds of cool stuff here, which I guess we're going to learn. Anyway, we're just going to finish the import. Okay. P2 all together. Dot. Okay.
Yeah. Gotta add the dot.
Mm-hmm.
Make PCA.
Okay, so we got to do a new model type somewhere.
Yeah, new
Click here to create one. PCA.
PCA. Training set. Click next.
Just training set.
Just because,
Just
Yeah,
training
so-
set.
think about it, we're building our model off the training set, and
Right.
then we're going to try to see how well we can
It predicts.
predict the predicted set
Are we?
based on that
Are
model.
we doing any wrenching?
We're gonna do the transform. You're skipping, or yeah, you're skipping ahead.
Okay, sorry.
It's okay. And then all the variables, all
including all
16
the-
variables.
Yeah, because that's one thing you can't exclude here.
Yes.
You know, one thing that's cool that I usually skip over is you can see kind of how that data,
Yeah.
you know, actually looks. So that's cool. Okay.
And then
Include all.
all 25. And
So
then
by
hit
default,
your
you
wrench.
don't have to say by default you don't have to click them all because you can see at the top
Yeah, it's
they're included.
yeah that they're included. Yes.
Yeah. By default, it just
And then, hit
automatically
your
as well.
wrench. Hit your wrench, Jim.
And transform.
And then transform. Yeah.
This is where we're going to apply the log.
Yep.
This is what I still don't understand. Why are we logging? Doing a log?
We're making the data, I feel like it's making the data more evenly spaced out.
Okay.
So like you use log plots to linearize things, and that way your data's not all like jammed up at one end or the other.
Okay. Gotcha. Abel, what were you saying?
No, yeah. What I remember is make the data to be visualized like easier. Like
Yeah.
Katie was saying, it's not skewed to one side or the other.
Right, because I seem to remember there was a bunch of it was skewed like over here, and then there was some stuff like spread out on some of them. So
Right.
Yeah, it's used for exponentials to make them flat. Because like,
Right.
so you use it like in biology and in chemistry for like decay.
Mhm.
And so if you were trying to graph like decay over time and you were trying to like interpolate off of it, it's easier to interpolate if you do it as a log plot versus a linear.
okay.
If that makes sense.
I'd say it's pretty. I feel like it's fairly common.
It's very
But-
common in certain industries.
Yep.
So here we're doing log,
So
right?
yeah, log, and then the constants. I assume the constants are just the way they are, and then you hit set because they didn't say to change any of it in the thing.
Yeah.
So,
All right. Then next.
and then, yep.
Are we doing any scaling? Is this the par scaling, or are we doing something else here?
No scaling.
It doesn't say.
It doesn't say to do it because by default that is hidden.
Okay.
So
Okay.
it's just the standard whatever scaling.
So in other words, it's just like that.
Yeah, pretty much.
And then we can just finish.
Yep.
Finito. Okay.
And then you need the first two components, right?
Well, it looks like it already did it.
It looks like it did it.
Yeah, that may be just
Yeah,
how
if
mine.
there's 2 for A, then you're good.
Yeah, that may be just how
Yeah.
mine is set. But if you didn't have anything, so like if I, so like let's just say, like I did this and excluded that one. Okay, then I could do two
Like
first.
first, yeah.
Right? So I could do that. So I'm going to delete that. Okay, so got an overview now. Let's see what we got. Okay. All right, so now what?
Once you do a class model, well, I mean, once you interpret, I guess, first.
Yeah, so what are we
Yeah.
interpreting? What are we thinking? I'm thinking it's going to be this one that we're going to do some interpreting on.
Well, first thing I see is there was 2 big groups, so that'd be interesting to look at.
So I'm going to sort it ascending.
Yeah.
So, I mean, you got this one here it explains a lot of the data and it's a good predictor. It explains a lot of
Same.
the data, not a great predictor. Explains a lot of the data, pretty good predictor. Same here. Explains a lot of the data, but hurts you. At least from what I remember, what he was saying.
Yeah.
Explains a lot of data, hurts you. Explains, hurts. Kind of all the way down. This doesn't really do much for you, and it hurts you.
Is that... Wait, a negative Q sum is hurts you?
Yeah, Q2 means it hurts. Means it hurts. It's the Q is the prediction score.
Just trying to understand what a negative predictive power would mean. To me, that would mean to be predictive.
You
No, I think it
could
means.
make you. Sorry.
Go ahead.
I don't know. Let me
Like
Google it
hurts.
statistically.
Hurts the amount of like division in your model, like hurts your groupings.
Yeah, I think it actually hurts you figuring out what's going on. Is the way I kind of understood it.
I don't remember if we went over that. We probably did.
We
My
did.
brain kind of stopped at some point, I think.
We did, and I have all that up. Matter of fact,
Okay.
he's gone over that a couple of times actually.
Okay.
So, but
Then I should know this.
well, that's the thing is it's not completely like sinking in because I don't know the data set or what exactly we're trying to do. We're learning the software, but then we're trying to learn the software and then apply it to something. Like, what does that tell me? Or is it telling me that FE doesn't explain the data and it hurts me? What it actually hurts anything I'm trying to do to predict anything.
Mm-hmm.
Is the way I understand.
I mean, I'm good with that.
Yeah, I remember we analyzed this for the principal components, right?
Right.
Not for the variables, but for the principal components.
Yeah.
Which one describes better?
Yeah, I just couldn't remember the negative. Yeah. Anyway, so to me, you see, I like the scores and loadings next to each other. That way you can kind of tell what's what.
Yeah.
But you can clearly see 2 groupings. One's more grouped. Can you do side by side?
What, these two? Yeah, I think I can do that.
Yeah.
What I'm learning is I feel like a lot of people, oh, did you not add the close all? Did you see how I did that the first day?
No.
No.
So on the next to the left of the label, at the very top. Yep, that thing.
This thing.
Yep. select what you want. So he added
Oh, I
close all
did add
windows,
Yeah.
tile horizontally, or I guess he did, or
He
he
did
did
both,
tile
I
vertically. Yeah, whatever. So now you can just, your hotkeys now, so you can just click that close all windows button. It closes everything. And then you can just now select, yeah,
Loading.
Here.
so you want scores and loadings, and then just click the, so it's like always there, which I've liked.
Okay.
So now you can see what predicts what, right? So your zinc and your sodium and aluminum are opposite each other on that right to left. So those seem to describe most of the variation between those two groups.
Yeah.
And then your variability, like how well it clusters in those two groups, is most described by lead and magnesium, mostly, maybe nickel. The up down is the kava. I guess that's C, right? Is kava
Yeah, I think so.
is
Thought
very spread out versus the champagne is closely grouped.
Yeah.
Yeah, you've got like a vertical dividing line. So what determines your group is mostly going to be those ones over to the far right and the far left, right?
Yeah.
If you're champagne or kava, yes.
So if you're kava, it's these two right here, right?
Yeah.
If you're champagne,
Well,
it's
yeah,
these.
I don't know the sign. I guess the sign would be that zinc is higher for the champagne and lower in sodium and aluminum,
Well,
and then vice versa for.
well, we can go do that. So you can select both of them and do a
Yep.
group-to-group comparison.
Yep, exactly.
Oh, what?
Yeah.
Yep.
This is super powerful.
Okay, yeah, I like that because I've
So-
been trying to figure the dang thing out.
So the zinc, right? And you double click on that. So you can see that the whichever one I clicked, I don't remember which one's which. So the
The first set.
yeah, I can't remember which one I clicked. So F is the first one I clicked. So that's going to be the blue one. So F is blue. Right? So F is blue, so it's generally higher in zinc. Okay, except for like one observation. This one's like kind of an outlier. But pretty much all the other ones are under the average line. Pretty much over the average line for that group.
Yep.
Yeah, that's super powerful. That's what we use a lot with OPLS is that group to group comparison. Well, that's what I was saying. Like, you know, let's compare every day that they make 130 tons or less versus 150 tons or more. And it will literally tell you what's different between those two groups. Like, here is all the stuff that we determine is different.
Yes.
So, yeah, it can be super handy.
Okay.
All right. So we did explain that. All right. What's next? So I'm gonna get.
It just says, I mean, we can look at solutions for part one if you'd like.
Yeah. Let's see tell me what they are. Like, what does it tell us? Did we get it right?
And then, I'm going to switch headsets real quick.
So part one. Yeah, so in the first component, zinc and aluminum and sodium have the highest loadings. High amounts of zinc and small amounts of aluminum or sodium indicate a champagne, and vice versa for kava.
Say that one more
That
time.
are, so high amounts of zinc and small amounts of aluminum and sodium
Right.
indicate champagne,
Okay.
versus and vice versa for kava.
Yep.
Okay.
So more sodium and aluminum mean kava, more zinc means champagne.
Okay. I'm looking at this graph that they've got. I'm trying to remember how they do that one.
Sorted loading plot. I think it's just a loadings, but with
Hit the
a
drop down
graph.
Is that
Yeah, that guy.
okay? So yeah, lots of aluminum. I mean, lots of zinc, and not much aluminum and sodium, right?
Yep.
Okay.
A lot of those ones in the middle don't make a difference.
Yeah, so
Right,
it
and there's big
said,
spread.
yeah, so magnesium, lead, cadmium, iron, nickel, copper. Is that copper? I think that's copper and manganese. They have magnesium twice. Seem to be little related to class separation.
Okay. Okay. Abel, does that all make sense?
Yeah.
Okay. Philip, you can answer there. Okay. We're thinking about you, man. We're thinking about you.
Speak into the void.
Yeah. All right.
It's like a kid's show and they ask you for a response or something.
Yeah. All right.
Like
All right. Let's go to task.
Dora the Explorer.
Exactly.
Yeah. Let's go to task 2.
Love it. All right, task 2.
So we're gonna change to a PCA class model.
All right. And so you see, I closed everything off, and then I just hit project again, so that popped this up.
Oh, look at you.
So I did it. So now.
So
One.
Art pinned that for me. I'm trying to think how you pin that. It's super nice just to leave that up at the top. Maybe
Oh
that's right.
yeah, I think it's it's
View maybe.
I don't know anymore.
Or do you right click the bar?
It was in one of the things of how to.
Right there. Now that's Data Explorer.
No. It might be
I
on
think
the
if you
tab.
try right-clicking the tab for it.
Yep, there you go.
No, never mind.
There's not a properties or anything.
Mm-mm.
Oh, there you go.
What?
Customize. That's probably not it. I don't know.
I think that's the model.
Dock project window is right there.
Where? What?
You just closed the window you needed.
Oh.
The thing we were just there.
Well, what was
So right click on the model itself.
customize?
Customize. Yep. Dock project
Down
window.
at the bottom. Yeah, dock project window.
There we go. Yeah.
There you go.
Yeah, because that's usually how I
recommend
had it.
doing that.
Yeah, that's
Exactly. And that way when you hit close all windows, you can still
You
see
still
the
have this.
data set you're working with.
yeah, that's good.
Yep.
So now,
This is, nice.
So
Do
now
the
we-
class model.
so now what do we need?
Class
PCA
model, the X.
PCA,
PCA
X.
class.
And then just add 1, right?
Yeah, which that was the thing that was not clear.
Yeah.
Yeah, I had to read that about 3 times before I understood what that meant.
This is the part I got stuck on. Okay. So you just hit add. So
Add,
just
add.
create a one component model. Okay.
Yeah, or you can auto fit and then remove a whole bunch. But yes,
Yeah.
Okay.
there are ways.
Yeah. Okay.
And they also labeled theirs, which they don't say. So the first one, so number 2,
Mm-hmm.
they labeled that as Kava. If you just kind of go over to the right where it says title,
Where?
and just click, go right. Right. Yeah. So just like click, double click there, I think,
Yeah.
and then just
you're
that's
right.
Kava.
Oh man.
That's nice.
Get down.
And then the
you
other
can
one
go
is
to that.
champagne, because they have their stuff labeled in the sheet, and I was like, how the heck do you do that?
Yeah.
Yep.
Man,
nice.
Philip's getting gold, like, because each of us have figured out one,
Little thing.
little things. This is why, like, Art's telling us to, like, work together. So this is good.
Yeah.
Mm-hmm. Okay.
All right. So
So
here,
you do that.
yeah. So here's where I got stuck. Is like use the procedure outlined in the previous task. Redo the predictive validation, but using the prediction set instead. Huh?
Oh yeah. Yeah. So what they want you to do?
I went down and read it, and I
Is-
finally figured it out. I was like, oh.
Yes, I had to go read the solution because I could not.
Yeah, because I was like, what the hell do you mean?
Yeah. How do you use one? Yeah, I found out if you try
Big
and
tab.
do like as data set here and you select the wrong thing, it will blow Simca up.
Yeah.
So make sure you save because it doesn't auto save.
No, it does not. So here I'll go ahead.
So yeah, if you click that and then you do the DMod XPS and
column.
columns. Yes. And then you go over to the right and you color by
Class.
the classes.
Yep.
To get it to be pretty.
All right. So F
So
is
I'm confused where the training set is right now. Training, or not training, but the prediction set.
So you're not using the prediction set yet. So this is
Okay.
task 2, where you're
what?
testing out the sets on.
Oh, we are.
Yeah.
Yeah, this is
Oh, this is
okay,
still
This is
task
task
2.
two.
Okay, still task 2. Okay.
So this is co-prediction, where they take the 6 sevenths and you use each of the sevenths. Okay,
Yeah.
gotcha. Predict it.
Yeah, so they're basically
So-
predicting that all of the champagnes would have been champagnes, and only one cava approached what a champagne might look like in this case.
Yeah. So you do it for both sets.
Right. So then you click this one and do a
Do
DMod.
the same thing. Yep. And then see which ones. I mean, so there's one that's
So this one definitely looks.
possibly better.
Yeah, this one looks better, right? Because everything's under and by substantially, and everything's over substantially, right? This outlier is what
Good.
hurts you.
And you can see which set it is now because we labeled them.
Yeah.
So
Very nice.
yeah. And then you do task 3.
So wait, how can you see which one's which? So you were just saying that.
Oh, so under the title it says like
Oh, cava.
champagne and cava. Yeah, then it's got comma cava or comma champagne.
Yep, so champagne one is the better one.
So cava is the training set versus this one
We're
champagne.
both in training sets
Say that
right
again.
now. We haven't used the prediction set yet. That's why I was confused.
Okay.
Yeah.
So
this
remember,
is
oh, go ahead, go ahead.
no, you're good.
So I'm just going to say, remember that there's a way to predict based on the same set of data, right? It takes 6 sevenths of the data
Oh yeah.
as your model and then does it compares it to the seventh.
Yeah.
So like did a little internally and it does that 7 times.
Right.
And that's what gives you this.
Okay.
Yeah.
But at least I believe that's the case.
Yeah, I think that's what. Yeah.
But later, I think we're going to switch it to using the actual prediction set that we set aside.
Okay.
So it's all completely new data. I think.
Okay.
Yeah, so that's like the cross, that's like training your model and then cross validation, and then you're going to do like your true validation with a completely separate set of data.
All right. Let's try that. How do we do that? Because I just finished that. Like I just gotten that part done right before this call.
So let's see here. You did procedure in the previous task, reading the predictive evaluation, but using the prediction set instead. Okay.
So go to
So-
predict. Oh, you want to run it?
Nope, you got it.
So go to predict, click on as data set,
Oh,
and then
the prediction set.
prediction set as data set. Yeah, so click prediction set. And then do a DMod, whatever, DMod XPS columns for those again with the class ID. Yep.
So that's not very good. The training set is
No.
not very good then.
That one isn't. So to do the other one and then do a side by side.
So we click that one as data set.
Yeah, it's already selected for prediction set, so you're good.
So we do the training set
It's
here.
already.
No, it's already selected. You don't have to click that again.
That's why I was confused about the top and bottom. That's why I asked that question because it is confusing. But it just like whatever you select on the top, whenever. Oh,
Well, you have to
yeah, you're already.
you have to select
So
something.
you have to
It's already
select. So
selected.
you selected model 2, and now you need to do again, but selecting model 3.
Right.
So as data set, prediction set's already selected, and then do DMod,
Oh, okay.
DMod XPS.
So that's
We're
already
using the
selected.
same old model, but we're choosing which one to predict on, and we
Yeah.
chose the prediction, the set aside prediction. So that model works well even with the prediction.
And again, the
So-
champagne wins.
The champagne predicts better what's fake champagne.
Okay.
Yep.
Okay.
Which makes sense because it was more grouped,
Yeah,
Yeah,
it's a
exactly.
narrower group.
which makes sense to me intuitively.
Right.
And then it wants you to do a Kumans plot
Yeah, hold-
on there too.
so
That's like the bonus. Okay.
Yeah, so go back to 2 and 3
yeah,
and
hold
then
on 1 second, because I went back.
Sorry.
No, it's fine. Like, what happened to the rest of our data there?
because you're looking at the prediction set.
Oh. Well, I thought I'm back to model 1.
Yeah, you are, but it's using the prediction set in it.
Oh.
Okay, so let me clarify something. I believe where it says diagnostics and interpretation on that home tab, where you do the overview and the scores and loadings and hotellings and all that stuff,
Mm-hmm.
that is the same stuff as that's what's on the predict tab.
Oh, okay.
So whatever you had selected is what's going to show up. It's not that these are two different sets of scores and loadings and predicted, I think. At least that's been my
Yeah.
experience.
Okay, you're right. Yep.
So when you hit
you have to go back and
loadings, you want
re-specify this.
which data set you want to predict on.
Right.
Yep.
So this is champagne class F,
Yep.
right? So it's grouped more tight
Yep.
versus, and you can even see the separation here. Right. This is a lot of times what we're looking for in some kind of a discriminant analysis where we're doing classes. We want separation. And a lot of times, like, I'll even look at that, 3D, like, do we have, separation in the entire group, or is it just in one dimension? So I like to, whenever we're trying to figure out, like, what's different between, like, running good, running bad, good quality, bad quality, or something like that, a lot of times I'll flip it in the 3D space and see it. The other way you can do it is hit the left and right arrow keys. Like, if you have more than 2 dimensions, if you have like 3, 4, 5, you can just hit the arrow key. Like, my left and right arrow key are getting it. So anyway, okay, last thing. So what we do now, we're doing a Kumans plot. What we got to do?
We're doing a Kumans plot.
All right. And so what are we doing the Kumans plot on? One of these or this up here?
I think it was model 1.
All right. Which is what I got.
Where do you find that?
Predict. Go back to predict. And go to Kumans plot. It's over on the right.
Yep.
At the top.
Kumans plot.
Mans. And I just left it the way it was because
Yeah.
they didn't really say to do something different.
And
And then change your label types. Which I would use the class ID instead of the number.
Yeah.
And then just hit OK and it should come out.
Yeah.
The way that theirs is.
And they're all nice.
That's
in their
different.
own spots.
Did you change data sets?
Nope, this is right.
No, that's not what they've got.
Well, he's on the training data, not the predict data.
Oh, right. Okay.
But that does neatly go in their own boxes, which means obviously it should be correctly identified if the model was good.
What did you just do? Oh.
I'm getting the same answer either way.
I think you have to just go change as data set
Yes.
and just go check prediction set.
There you go. Now do it in spot.
Yeah, there you go. So there's one ambiguous. Wow.
That's easy for you to say. Yeah, so you got 5 down here and 4 up there. And then 1 that you're like, I don't know.
Yeah,
And this was
one they didn't
this was
know.
just on the training set right there? Or I mean the prediction set?
Yeah, that's on the prediction set.
Okay.
But I don't like the word training and prediction. I mean, it does make sense, but it's confusing to me. It's like One's the model build, like the one you build a model, and the ones you test.
Yeah.
Yeah.
I mean, it's like a model set and a test set to me, in my head.
Yeah, like model and validation.
Yeah, exactly.
Yeah.
Okay. So the conclusion is possible to set up reliable classifiers for Champagne. This means this.
Oh man, your Florida's showing there.
Yeah. This. It's called being in the South for 29 years, or no, 20. I don't know how long have I been here since '88. I did this the other day, 34 years. So it's a long time. So I it goes past like the fingers and toes. Like I struggle past that, past 20. That's just something you inherit when you move down here long enough and live here long enough. This means a classifier can be used to differentiate between expensive champagne and less expensive sparkling wines. So Cava has a broader variation. So champagne's narrower in variation.
Which makes sense logically.
Yeah. I'm trying to figure out like where we would use this.
Could be like raw materials.
Yeah.
It could be
You're right. We could do raw material.
like up, down, uptime, downtime, on spec, off specs.
Could be. Yeah.
I mean, if you have any sort of, if they ever had an oil or grease or like some sort of spectral stuff on that,
Yeah.
you could build a model off of what that is and then what's not.
Okay.
Yeah, that's
Or it's something else, you could identify what it is that's good rather than if you know what it should be made of.
Okay.
There's all sorts of things.
All right. Cool. All right. I'm done sharing. All right.
Okay.
So who's driving next?
Which one do we want to do?
Gonna drive.
Sure.
I'm interested in that Volvo one.
Do it.
Or beer. I mean, we know.
Well, if it doesn't have Modelo Negra, I mean, we're gonna lose the bell.
Oh. If it doesn't have girly beer, you're gonna lose me.
So here we go. Girly beer versus Modelo Negra.
Versus whatever craft brews Ben is drinking.
Yeah.
Yeah.
Versus like an amber ale to me.
Crack open
And
the
what does
Farms
Philip
Red
drink?
one night.
You can answer later, Philip.
I'm trying to remember what did he have that night. He's had some craft beer stuff I think when we got together. So anyway,
Awesome.
all right, cool. All right, I'm gonna mute and I'm gonna run to the restroom real quick while whoever's drives.
We can't see your video. At least I can. I don't know what happened to your camera.
Yeah, I know.
Okay.
I killed my camera off because I was struggling with, like, every time I turn my camera on, like, my internet gets goofy when I'm on Teams. So,
Okay.
all right. So who's driving? Share your screen.
We'll get it. Katie, you want to drive or you want me to
I
drive?
can drive. Yeah. Let me pull the exercise up.
Or Belle can have a drive. I guess how many? Yeah.
I was gonna say each of us can have a drive. You know.
I'm thinking.
So which one are we doing now? Because I'm
We're gonna do beer.
do Burr.
Let
Burr.
me share my screen.
All right, I'll be right back.
Okie doke.
That's the beer NIR one.
Yeah, I'm just, come on, computer. Good grief. Okay. Just trying to get it in the right window so I'm not, like, doing stupid things. All right. Okay, can everybody see my screen? Okay, so we're gonna look at 50 different beer samples for
Yep.
alcohol content. Cool.
Your primary question session is it possible to use NIR for rapid determination of alcohol content? Yep. Okay.
NIR is cool. Okay,
Never really
so
used it. It sounds cool.
it is very cool. I've used it at one of the plants I worked at for like online quality monitoring of reactions and like endpoint determination. It was fun. So we're gonna make a new spectroscopy project from beer NIR. So
We wait for Jim, or
I can wait for Jim.
no? I mean, you can pull the data in if you want.
I'm just gonna open the
At least get to
data.
that point. Yep.
Okay.
We got the.
So we got to do some cleanups. So
Yep.
import wizard, define the wavelength axis as spectral ID, which is this guy. Spectral ID.
Row. Yep.
That's defined. This is primary IDs. That's primary ID. So, oh, nope. So this is secondary ID. Then alcohol, color, pH, and bitterness are going to be Y variables.
Yes, we're trying to predict those
Yeah.
based off of the spectral samples, I guess.
And then we have a warning because the wavelength information is not applicable because there's nothing here. So we have to resolve all.
Split it, I think, doesn't it?
That's what it wanted us to do. So we have two data sets now, one for X and one for Y. We suggest you edit the name of each data set to something that will facilitate the understanding. Okay.
Under the normal stuff, and one's the spectra, I guess.
So this is X variables. This is spectra.
Yep.
So what did you do? Just double click on it to rename?
Yeah. You double click, and then this is properties, which is Y.
Yep.
And we're gonna plot the raw data home tab spectra button.
Oh, we haven't imported yet.
Oh, finish import, right. Okay. We're gonna finish import. Okay. Now we're gonna plot the raw data. So home, spectra. We have spectra. Ooh, we got some wacky ones.
Yep, we sure do.
Okay. So
Right. That's pretty cool. It shows you the wavelength and what flared at those wavelengths. You can see just a couple major spikes.
So according to the solutions, this wacky one is the spectra of pure ethanol.
Makes sense.
It says
the other one's water.
Says the one. So at first glance, all the beer spectra seem very similar. The one deviating spectrum is the spectrum of pure ethanol, whereas the pure water sample resembles the beer spectra and is not possible to separate from looking at the spectra. So water is here.
Oh, it does. It's in the group, I guess.
Which one is that? Oh. Yeah, so it's the sky that's sort of like a dark gray and really hard to see.
Yep.
And then in the low spectra region, which I can unclick the beer, so down here, it's the visual spectra range, 400 to 700 nanometers, and reflects the difference in color, which makes sense. So there's a big spread down there.
That would make sense. More closer to the visible range.
Yes.
You would get the color. Yep.
You would. Let's see. So the next, we're going to go to task 2. We're going to create a PCA model of all 50 beer samples and their NIR spectra to explore patterns and trends. And we have to change the default UV scaling, which is going to be fun.
So I'm assuming this is something like what we're going to have to do for Wilford, right? Is you've got spectral data versus other data in this
Yes.
case?
Yes, I would think so. So we're gonna make a new model. I'm gonna hit my wrench and add scale to it. We're gonna make an overview PCA. Hit next. We're hitting the spectra. Hit next. We want all 1050 variables. We want to view the name of each beer variety. Right click. Oh, so we're going to add the name of the beers just so that we can see. And we don't want ethanol and water. So I'm going to click both of those and exclude them. So now they no longer checked. I will hit next. So,
And the cool thing is
We're
your
gonna-
data is not being touched. This is just literally a work set that you're that
Yeah.
you're messing with. So like if you want to do another model where you do use water and ethanol, you can do it and not exclude it, and it doesn't blow your whole data set up.
which is nice. We're
don't
gonna.
need it.
Sorry, what?
we don't need to transform anything, right?
Oh yeah, no. That's right. We don't need to transform. Next, we're gonna scale though. So I've selected everything. We're gonna center it. So we're not using UV. We're gonna use centering, and we're gonna set.
All right, so I'm confused. Why would we do that? Other than it told us
Because
to.
it said to.
Yeah, I mean that's the thing is I'm like, okay, well it says center it. Well, why? What's the criteria here? Because I mean, think about it. We're gonna be working on our own, with
Yeah.
data sets. Like we have to understand why. Like, okay, we're
Yeah.
navigating the software. Okay, we can see how to do it. Like any of us can figure that out, but why? So anyway, all right. Question. Question for you.
I don't
Add it.
know.
Should
we
add
make,
that to a
like-
list of questions?
Yep.
Yeah, I was just about to say, should we make a list of questions?
Yeah.
So we're doing centered, and now we're going to say next, and then we're going to make sure that matches the thing, and then we're going to do PCA model, and we're going to do first two components and hit finish. Which is pretty good. So we're gonna auto fit the model. Why did it have us do that if it's gonna have us immediately auto fit?
I don't know if they want us to do that. I think autofit was, but the screenshot had first two components.
Yeah, I think autofit.
Well, no,
automatically
it
runs
does.
on the
You're right,
first one.
it did say it. It did say it.
It
You're
says
right.
select first two components, and then it immediately says to auto fit. I don't understand.
See if it comes up with more than two components.
10.
Dang. So what's interesting is like just in the first component, like 90% can be explained and 90% predictive. Like if I see this, I'm like, all right, there's something wrong with the data. Nothing can be this perfect.
Yeah.
That's in our world. That's like exactly what I think. I'm like, uh-oh, something's not right.
I think it's anybody's world for this amount. This looks not right.
Yeah.
Yeah. So if we just did 2 first, it's
Yep.
0.986, 0.984, which is
Pretty amazing.
pretty reasonable.
Ridiculously high.
Yeah.
This means that there's one thing that determines it. Probably.
Yes.
Score
Probably.
plot. Okay.
I just did that for fun. And I don't think I should have. I think that was a bad idea, actually.
Should be able to hit Control Z a couple times, I think.
Yeah, it's not undoable. That's
Close
okay.
all. Hit scores and loadings again.
I can hit overview again, and
Yep.
it's fine. Yeah, because it undid the sort by the spectra, I think. Oh yeah, so we were looking at summary of it here. Or were we? Do we care? Explore the patterns in the first two principal components and display the score plot to get an overview of the 50 beer samples. So we've got some serious outliers. Try to edit the label and coloring of the score plot to visualize trends.
So let's
So
add a label.
by name.
I mean, it gives you an idea.
Yeah.
Some stuff. I would want to add like the Y variables, like the color and pH and stuff like that, right? That's what I would think. but
Yeah, can you though?
That's what I'm
Do
confused
more
about. The
options.
labels.
When you do that, there's more options there.
Oh, coloring type identifiers. It just gives you the names of the beers. I guess you can do patterns.
Mm-mm.
I don't
Did
know.
we not select it as like a secondary ID maybe? In our data set?
Well, it wasn't a secondary ID. They're Y category or Ys, right?
True. Let's see, try to add the label.
Say okay right there, but when you do density.
That's not density like you're thinking it.
Well, no, but I'm just saying you should be able to color by. Yeah, you're coloring by density. So like higher.
That's not actual density. That's like data density.
That's data density. Okay.
I think.
Yeah.
I don't think it's.
Because the other Y's would be in there.
Oh yeah, here we go. Here we can do vector. We can do
There we go. I knew it was
alcohol, color, pH,
There
or
we go.
bitterness.
in there. Awesome. I think you'll find the color one is very interesting. But yeah, try alcohol.
Yeah, I know Ben and I used this one time, and you can change the split ranges too.
Oh, that's fun. So you can see what the alcohol content is split out.
Yep. Pretty neat.
There's some of those crazy
So there
craft beers.
is some groupings.
And then I can change it over here. Now I've got it set up. So
Yeah,
let's
in
see
fact,
color.
I think you can do it by arrow keys as well, I believe.
If it's selected? No?
I forget if you just click the plot. Oh, maybe not. That's something else. Never mind. It's like, yeah, color.
Oh, wait.
Oh,
It's doing stupid things. Hang on a second.
the scaling part is
The scaling is all screwed up.
Can we just do like auto?
I don't-
There you go.
Don't know.
Just don't. Yeah, just leave it like that. Don't add categories.
You have to add categories.
Yeah, so change it to pH. See what happens.
Yeah, I just have to add categories.
Yep.
Okay, every time you move it.
Yeah, and then you can do a split range, whatever range you want, and then you could go in and
Sure,
edit these
I got it.
manually.
Makes sense.
So now you can see.
Yeah, probably pick some for you based on the data. But if you wanted to
Yeah.
put it into 6 split ranges, you could. I know Ben and I have done this before. I'm trying to remember what we were doing, but we figured this out. Yeah, and hit apply. Just see what it looks like.
Yeah.
So you can do
Yep.
that.
Can you do color again? Because I'm pretty sure that's the one we were.
Yep.
Button.
Yeah.
Yep. So you can see kind of the outliers are based on color.
Yeah.
Oop.
They're all pretty big ranges, actually. You could do even more categories.
But it's like you go super dark and it goes off to the right there.
Yeah. It's interesting.
Okay.
We did alcohol. We didn't do bitterness. All over the place.
All right, so here's something you can do. So just for kicks, let's go back. Whichever one gave us the best split. Which one was it?
Probably the color.
Okay.
Okay.
All right. So now just highlight all the like green and red ones out there. So you just click and hold, and yeah, you can, and then just highlight the other one too. You can get them all. Okay.
Okay.
And then click the blue grouping up on that top right. Just go straight above your, nope, top right to your mouse. I'm sorry, up and right there. Click that. That should click the other grouping. All right, now do a group to group comparison. So you're comparing those three with the other group.
Yeah, I was going to say you could have just done group to average.
Yeah, you could do group to average too. Yeah.
It's kind of hard to see on a spectrum.
It is, isn't it?
Mm-hmm.
Yeah. Okay.
What
So
areas contribute to it, I guess.
I don't know if you can do. XSX. No, that's not going to help in this case. It's not enough. Okay. Okay. So we did group to group.
You can look at the loadings and see what parts of the spectra are responsible for the separation of beer samples. So it'd be
Here?
the visible, right? Yep. So
Well,
the low end, it looks like, is more is the part that matters more, I guess. Is that what that's saying? So
what?
for the loadings, basically we're saying that the low
Oh,
frequency
right.
stuff
Yeah,
is
this
the stuff that contributes the most to the model.
which makes sense.
So basically it's saying that what's providing the separation is color, I think.
Yeah, it's those under 800,
Yep.
700, 800
Which
nanometers.
happens to be visible, so
Yeah.
that would mean that's what's providing most of the split.
Okay. Yeah, I was having some trouble interpreting what this plot
Yep.
was.
I think that's what it's saying. I mean, there's a little blip at 14 something, which I think that's, again, if I remember the ethanol curve, those are probably, some of those blips are probably similar to that. So it's like maybe alcohol content contributes to some of those like components,
Mm-hmm.
but it's not a lot because there are some in different areas.
Yeah.
I think that's what that's saying. It's like what parts of the spectra are contributing to the, or loading into our principal component. And so that'd be mostly the low end stuff and a couple little blips. I think.
Hmm. So we know what this is. So then in the solutions that I'm not copying clearly, so this explains this spread left to right, color does, but then it looks like alcohol explains the color top to bottom.
Look at that.
Yep. So you've got,
Yep.
for the most part, like more alcohol, is vertical
Yep.
direction.
The color and alcohol are what separate the beer mostly.
Mm-hmm.
Most of the variation. That makes sense.
Yeah.
Out of pH and bitterness.
Yep. So yeah, pH and bitterness weren't really. Let's see, pH. I don't think it was especially enlightening. It's all mixed up. And then bitterness was also all mixed up. Which, let's see, that would be interesting. So this is bitterness. I wonder if it kind of looked like pH was kind of associated with bitterness.
That would make sense. But it doesn't predict.
Yeah, maybe.
Not the biggest variation.
No, it doesn't really predict variation. So,
yeah.
All right.
Cool.
Oh, I should put it back to what we had before. The alcohol, or do we want to look at alcohol or do we want to look at color?
It's up to you. We're about to do more of it anyway.
You what?
So you're about to do more the next step anyway.
Yep. So they had an interesting... Oh, so they did both components on here. They overlaid them somehow on this chart, and I don't know how.
I guess that's one way to do it. Nice.
There.
Hey, look at that.
So now we
What?
can see what does... So component 1, component 2.
Interesting. So we're saying, okay, so how much does component 1 load in?
Component 1 is this way.
Yes.
So component 1 we've figured out is color.
Yep. Which makes sense. It'd be the low frequencies that contribute.
And then that's alcohol.
Okay, so it's not. Oh, that makes sense. So in the other way, that should look like our ethanol curve-ish.
Which it does.
It's
Look at that. It's inverted.
Inverted, but it's still
kind of.
Yeah.
This peak area is inverted.
Yep.
It's kind
Which
of
makes sense because it's not going to be perfect because it's just a loading, it's a projection, but it's you can see the shadow of it essentially.
Guys, how do I
get
get
variation?
rid of this plot? There it is. Okay. Okay. Anyways,
Cool.
so
that makes me feel happy.
That's cool. So next, we're going to make an OPLS model on alcohol content. So we're going to make a new model. Goodbye, screens. Create a new model. We're going to do an OPLS.
Mm-hmm.
Select both data sets.
Yep. I'm just going to try to use that to predict
that Y equals alcohol. Okay, so we got a Y equals alcohol as the single variable.
Right, we're just going to do 1 Y rather than 3.
And so we're going to exclude these 3.
Yep.
And we have all the 1050
X's.
X's.
Yep.
Next. We're going to ditch ethanol and water again.
Oh,
wait.
Need to get add scale.
I got to add scale again.
It wants us to center it again.
Yeah.
I'm assuming maybe it's just, I wonder why, but I'm guessing it has to do with the type of spectral data. So I wonder if that's just how, like, standard practice for spectral data.
Probably. I just don't understand why. So we're going to scale center.
I have that written down, so.
Okay.
Good question.
Oh, I guess I need to click all of them, don't I?
Yes, you do.
Okay. So now they're centered.
Yep.
Hopefully I didn't accidentally center something twice.
I think you're all right.
Do you think I should center the Y too, right? So that it gets the same kind of weird scaling as the X's?
It does say center the spectral data.
Yeah, that's why I'm...
I don't know.
Oh, no, it looks like no. Here, so this, looking at my cheat sheet,
UV.
it looks like UV on Y.
Okay.
So I need to understand. Yeah, that's a question. Why use one and?
Yeah.
Interesting. Yep.
Oh my gosh, Lulu is wagging her tail in her sleep. It's really cute, guys. Sorry. Okay. Okay, I centered all these. This has been UV'd. I wonder if I need to redo the centering now that I unselected the Y.
This is centered.
No, you should be good.
I think it changed. I don't know.
Yeah, they're all centered and you have one UV, so you're good.
Okay. And then hit next. And then this time it told us to autofit.
Make sure you pick OPLS.
Yeah, model type.
Why does it change that?
You have to wait till the end to pick it. So
What? It literally said that I had selected an OPLS model up there.
Yeah, I thought I did too. That's weird.
Dumb. Okay. All right, so I'm gonna hit finish. So this is our OPLS.
I'm hoping we didn't double, triple scale, or if that is a difference. That's what I'm worried about.
yeah, so go to
Although, no, that looks like what they have.
yeah, go to scores here. Just click scores. All right, and then hit your right arrow key.
Hmm?
I did.
Didn't change. Can you click the graph, click the score, and hit right?
I am. Yeah.
Okay.
Or hit
Not changing.
hit up and down then. There you go. So you should be able to go flip through all of the components right here. And then if you go to scores and hit 3D, you can see it all. You have one selected right now.
I guess we should color by. Let me change the coloring because now we're looking at alcohol, right? So, because we're trying to predict the alcohol, so it would make more sense to do alcohol content.
Do your
here.
scores in 3D. Let's see what it looks like. So just click the down arrow on the scores.
Okay.
I like 3D. It's cool.
We know you like the 3D one.
There's like nobody at Simcoe seems to like 3D. It's kind of interesting.
I know, but
However, there are certain customers that use it for sure a lot.
like for me, I just think it gives me a good idea of separation. I can't flipping through the different pages. I can't tell. Right here, you can definitely tell that the two red ones are like out in the same direction. The two blues, you get on certain pages and it won't look like they're out, or they look like they're out, in the same direction, but they're really not. They are, but they're not.
Yeah. The tricky part though is that you're predicting on the plane rather than on the 3D.
Right.
So
True.
you gotta see the separation in 2D anyway.
But to me, in an OPLS plot, I like the separation. Yeah, if you want to make yourself dizzy, spin it.
To me, the 3D makes a lot of sense for group-to-group comparisons because you can select them
Correct.
specifically better.
Well,
maybe.
and you can see the separation in the groups. Like, are these groups really separated in all dimensions, or just one or two? Right? Because I've seen some of them not.
So
You're zooming in.
yeah. So the question is though, do we need all 5 principal components in this, or 4? I guess.
I don't know.
Yeah, so go back to, what was it? Summary of fit.
Okay.
So, I mean,
This one doesn't.
to me,
so that-
you could pick 2 or 3 to me. Like 4 and 5 are kind of redundant.
This is one, because it's 2 different things, right? So there's the 1 and 4. Right. I forget exactly. So that's I'm trying to remember how this works because it's different with OPLS. Is right because it's 1, 4 versus just how many principal components.
Yeah, I'll write that down as a question. What does the 1 plus 4
Yep.
mean?
Yeah, just recall what that means. Yeah, because I would think we do like 1 plus 2, maybe 3. Most anyway. Maybe we should just go to the task because we have we're spending a lot of time. I mean, it's good stuff, but I just want to make sure we're cognizant of all that. It's already been an hour and a half.
Is it? Oh my gosh! Yeah, I have to stop at 3 because
Yeah.
I've got an AI meeting.
Yep, that's what I'm saying. So let's.
Yeah, let's finish this one and call it good. I think. Abel, are you feeling good about it or better about it?
Yes.
Thanks, Abel.
Oh, sorry. Sorry, I didn't hear who you asked. Sorry, Belle.
It's okay. How are you feeling?
Starting to make a bit more sense.
Yeah, it's
Try to find
still gonna take practice.
the groupings. Yeah.
Yeah,
But it's gonna be interesting to if R can load the data you were talking about at the beginning
right.
and see how he tackles that.
Exactly.
Since that's a real use case from a process.
Yeah, no doubt.
Yep.
Yep, no doubt. So, okay. All right, so let's go ahead and finish this example, and then we'll call it done.
Okay. Excuse me. So, it says an OPLS model with alcohol content as the single response gave a 5-component model with R squared of 0.99 or R2 of 0.99 and Q2 of 0.98. This reveals that the NIR spectra certainly are related to the alcohol content. Notice, however, that only around 9% of the variation in the NIR spectra are related to the alcohol content.
Okay, so the first one is. Whoa, wait, hold on.
So this,
Wait,
I
how do
don't-
we know?
I don't know. Okay, so it looks like they're doing some kind of a model analysis. Is it a report? No.
Single response. Okay, yeah. So 1Y. If I could.
No, that's not it. Your models is the statistics. No.
So the first one describes the variation of. I don't understand that.
Summary of the.
Oh, the R2X. Oh, look at the see how they have like the model? Can you pull that up? Oh, let me see here.
Oh, wow.
Right here.
I'm smart. Okay.
Okay. So they've got the predictive and then the 4 other components.
Just this way.
Where's that?
Yep. So
Okay.
predictive is this guy. This P1, component 1. It's very predictive, but it's not.
It only describes a tiny bit of the variation.
Yeah, it's only a tiny bit of the spectra and variation, but it's very predictive. And then these explain a lot of tell me if I'm wrong here. These explain a lot. No, they don't explain very much variation either.
Yep.
Okay.
So they don't. So this when we're saying variation, we're saying variation in alcohol. No.
I don't know.
Sure.
RMSEE can be
Mean
used.
squared error.
Listed in this plot? What? No, it's not. .14%.
Confused
I don't
why
understand.
it's split.
Huh?
Go ahead. Yeah, I'm confused why it's split.
So here it says this model can be illustrated by plotting observed by versus predicted Y values. The RMSE value is listed in this plot. Oh, we gotta.
Oh, duh.
gotta do another thing. Just doesn't show a picture of it, so I didn't understand what they were asking me to do. So we want to plot. Wow. Straight up.
So it's like, okay, since we have, we're basically saying, okay, build a model that it's a 4-component model, and then we're saying, okay, using that model, if we used all of our same inputs from our Y values or whatever, or our knowns, would we get our predicted or our actual Y values? Like, would we?
Yeah.
How close would we get?
So I think it's
get
Yeah, I think so too.
real world answers using our model.
So
And the answer is we get pretty dang close, but it only describes some of the variation in alcohol.
show the RMSE, does it? Or is that what it is? I don't know. So it says observe versus predicted Y values. To plot the observed versus predicted Y. Oh, is it this observe versus? Oh, duh.
Yes, because
Yeah.
our
That
model.
makes more sense.
If we put all our inputs back into our model, do we get our observed outputs? And how close is it?
Here's our RMSE down here. 0.139.
It looks like it describes it pretty well. I think, right?
It provides an estimate of the average prediction error. In this case, it is 0.14% alcohol, which can be compared with the range in alcohol content and the precision and accuracy of the reference analysis method.
So it's instrument error, so that means we're pretty good, I guess.
Well, so it says it's based only on the model and thus it's not validated. So in order to obtain a more realistic view of the prediction error, the model needs to be tested with a new and independent test from which the RMSEP value can be calculated. I'm gonna pretend I fully understand that. I don't know what it's saying all the way there. I don't remember this RMSEP coming up before.
No, he hasn't taught that yet. So I guess they didn't have to amputate from the neck up on Philip. He's here.
Oh, hi, Philip.
Hey.
So we figured out a lot of stuff. So I think you'll have some good stuff to go back and watch on the recording. So I'll try to have that up over the weekend. So it takes a little while to process and upload.
Sure. Yeah, what assignment are you guys on?
The beer NIR.
Yeah, we did champagne versus cava, and then we decided to do the beer one. So it's helped a lot. I think just running through it, like each of us kind of picked something out, you know.
Yeah.
Although, has anybody noticed, this is just a stupid thing, has anybody noticed that, like, the tab names are totally unrelated to what's actually the tab? Like, the overview says purchase requisition form.
Yeah.
And the one for beer says MBDA exercise on carrageenan.
Oh my.
Lovely.
It's kind of a hot mess. Okay.
Fun.
Off topic.
Yeah, mine says the same.
So I don't know how they did. So they said for interpretation, a loading line plot of P for the first OPLS component is shown below. I don't know how they're doing some of these graphs.
And you
Loading
create.
line
You can hit create.
plot. Create.
Oh, it's a loading though. You can just do a
It's a-
line plot of anything right there. But if it's a loading line plot, then
Loading line plot.
It said.
Ah.
There you go. It looks like the ethanol curve to me again,
It looks like the ethanol curve kind
with
of
some other stuff.
inverted. So this was, I don't know what this is. Spectral regions that are important for the correlation to alcohol. Blah, blah, blah.
Yep, so between that 2000 and 2400 wavelength is pretty important. At 1400, is it 1400 plus?
What is that? Sorry.
But yeah, so it just shows you what wavelengths are important, right?
Yeah.
So you got that 14 to 1500 peak. You got a peak at 1900 to 2000 or whatever that is, 1900.
Mm-hmm.
Yeah, so it just kind of tells you what to pay attention to, I guess.
Yeah. Oh, never mind. That's this plot without color. I'm having a day. Yeah. Okay. Yeah, I guess it just tells you what's important to the model. So like this area is important. Stop it. This area I'm circling with my mouse
Yeah.
is important to this
Yeah.
model.
It's what contributes, it loads into the prediction, I guess, right? So those are the areas that are most influential to predicting our alcohol content, which would make sense that the ethanol curve would predict alcohol.
Yep.
Right? Or something that resembles it.
Yeah.
Those same frequencies, I should say.
So would we say that NIR can be used for the determination of alcohol content?
Yes. I think
so. I mean, it seems like it's...
What do they say?
They said, in a roundabout way, I think they said yes, but you need to test it more.
Yeah, sure.
Do we want to do task 4?
What is it? Let's see.
It's explaining pH and bitterness in like seeing if NIR can do pH and bitterness.
Oh, I see. It's the same thing, but just switching the variable.
Yeah.
It's up to you all.
I'm okay skipping it. Does anybody else want to drive? I guess we're probably kind of low on time.
Yeah, I would say we're kind of low on time, so I would say,
Yeah, I think we got a good stab at it. We've got some questions at least.
yeah. And we can do, like, I would say, let me look at these exercises again. Let's see, which other ones did he have us do? Because I had them highlighted, and then, like, I closed it and didn't ask us.
Beer, Volvo, and then the Q from one potentially.
Was that? I don't remember that.
Yeah, that's what I was
Those
thinking.
are the 3 I wrote down. Volvo, beer, and Cuprum.
Yeah. Okay. Why don't we try that one? Because
Cuprum?
we'll probably get stuck big time. But let's do that one. Try to do that one for Monday. Like I was just gonna try to do it maybe like from like 10 to 11.
Mm-hmm.
On Monday.
You're saying yeah, like do it before on Monday.
Yeah.
Agreed.
That was my.
That makes sense to
my
me.
thought. I mean,
How many click through Volvo? At least read through.
yeah. I
it?
mean, the fact is, we're getting some practice and practice together.
Yep.
You know, now we have questions. And Philip, one thing that we were going to tell you is I took some data from Pactiv. I'm going to anonymize it and say, okay, I got 250 columns. It's hourly readings for the last, almost 3 years, like 2 years and 10 months. We know that they're having problems where they're not running, at what their capacity is, and we would like to see what we can figure out. What do we do? walk us through it. Like, what would you do?
Right.
And so then that way we can just kind of look at the data set together and, all right, what would you, walk us through your thought process on all that. I think that'll bring a lot of it home. So,
Yeah.
and I'll kind of anonymize the data. So, okay. All right.
Yeah, I'll probably do this tomorrow and go through the video. I can't really see the way they validated my people.
Yeah, that makes it hard to see.
Yeah.
So, all right, I'm gonna go ahead and
Yeah, I was like,
stop
how long is the
recording.
class? They're like 4 to